Let's think for a second about the simple, predictable fall of an apple. Now contrast that with the massive, swirling chaos of the entire cosmos. Welcome to this explainer. Today, we're actually going to look at the literal source code of the universe. We're talking about physics. We're going to peel back the layers of reality together to understand the invisible mechanics that dictate how absolutely everything around us operates.
So what is matter actually made of? And how in the world did the universe even begin? These aren't just late-night philosophical musings. These are the precise, mechanical questions that physics actively seeks to answer. Think about the sheer magnitude of that for a second. We are quite literally a collection of atoms trying to understand the rules governing all atoms. Physics goes way beyond just describing what things look like. It digs into the exact mathematical why and how behind motion, light, gravity, and really the very dawn of time itself.
To break this all down, we're going to cover 5 main areas. First, the science of everything. Second, the rules of the universe. Third, the experimental method. Fourth, physics in our daily lives. And finally, we'll look out at the edge of the unknown.
Okay, let's jump right into Section 1, the science of everything, where we lay the foundation.
The word itself comes from the Greek word physis, which simply means nature. And at its core, physics is the study of matter, energy, motion, space, time, and the fundamental forces. It's the absolute bedrock of reality. Think about it this way. When you really break it down, chemistry is kind of just applied physics. Biology, that's just applied chemistry. And fields like geology and astronomy are completely governed by these exact same base mechanics. So when a physicist looks at a tree, they don't just see leaves and bark. No, they see carbon atoms bonded by electromagnetic forces, absorbing photons that just traveled millions of miles from a star to trigger a chemical reaction. Without understanding this foundational layer, modern science just simply wouldn't exist.
Now, to actually understand the universe, we need a universal alphabet, right? And that's exactly what the International System of Units, or SI units, provides. It gives us a completely objective framework. Whether we're measuring the time it takes a distant pulsar to complete one rotation in seconds, the extreme heat of a supernova in Kelvin, or the massive thrust of a rocket engine in newtons, this standardized language lets us objectively describe reality, literally anywhere in the cosmos. It perfectly bridges the gap between a scientist in Tokyo, a researcher in Geneva, and hey, even a hypothetical alien civilization across the galaxy. Because a fundamental physical quantity isn't just an opinion, it's a measurable, undeniable fact of nature.
Moving on to Section 2, the rules of the universe. Let's talk about the invisible forces.
I want you to just think about the sheer complexity of the universe for a second. We're talking billions of galaxies, trillions of planets, the infinite variations of life, weather, geology, the whole shebang. Now consider this mind-blowing fact. Absolutely all physical phenomena, from a collapsing star to a firing neuron in your brain, arise from just 4 fundamental interactions. 4! Just 4 rules govern absolutely everything that has ever happened, is happening right now, or ever will happen.
So what are they? Well, first you have gravitation. This is basically the macro manager. It keeps our feet on the ground, dictates the ocean tides, and meticulously scripts the orbits of planets around stars. Then there's electromagnetism, which basically runs the show at the human scale. It gives us light, electricity, and the entire chemical foundation of our bodies. But when you dive deep down inside an atom, the rules completely change. Down there, the strong interaction acts as this cosmic glue. It's a massively powerful force that actually overcomes the repulsion of protons just to hold the nucleus of an atom together. And finally, the weak interaction. This one is responsible for the strange transformative process of radioactive decay, which, by the way, is the exact mechanism that allows the sun to burn and bathe our planet in energy. Just 4 distinct forces, seamlessly holding all of reality together.
Now, physicists take these universal laws and express them mathematically. Take Albert Einstein's incredibly famous E equals mc squared. It isn't just a widely recognized string of letters and numbers, it's a profound realization that mass and energy are essentially 2 sides of the exact same coin. It dictates that a tiny, almost microscopic amount of physical matter actually contains an unfathomable, staggering amount of energy just waiting to be unlocked. It literally changed how humanity views the fabric of reality forever. You see, mathematics is the true language of the cosmos, translating all these chaotic physical interactions into elegant, incredibly predictive models.
All right, Section 3, the experimental method. Let's look at exactly how we know what we know.
Here's the thing. Physics isn't about guessing. It is all about proving. It really separates itself from pure philosophy through the experimental method. And this is a rigorous, unforgiving staircase of logic. You observe a strange quirk in nature, you guess how it works by forming a testable hypothesis, and then, this is the crucial part, you relentlessly try to prove yourself wrong with highly controlled experiments. Honestly, a failed experiment in physics is often just as valuable as a successful one because it narrows the field of truth. Only when the math and the physical data align flawlessly, repeatedly, and universally does a theory actually emerge. And a true physical theory doesn't just explain the past, it allows us to predict the future behavior of the universe with staggering precision.
Which brings us to Section 4, Physics in Daily Life. Let's take this from the abstract to the applied.
Now you might be thinking physics is just theoretical equations on a dusty chalkboard. But it's actually happening around you constantly, and on two entirely different, almost contradictory scales. On one hand, you have classical mechanics. This governs the predictable macro world you experience every single second. It's the friction of your car tires on the asphalt, the structural load on a bridge, the aerodynamics keeping a commercial jet in the sky. But if you zoom in closer, down to the atomic level, quantum mechanics completely takes over. And down there, all that predictability just vanishes. It's replaced by the bizarre probabilistic behavior of the subatomic particles that literally make up your DNA. And crazy enough, we exist right at the intersection of these two distinct realities.
Because of our understanding of this, every single piece of modern technology you use is really just applied physics. When you heat up leftovers in a microwave, you're utilizing electromagnetic radiation at the exact frequency required to excite water molecules and generate heat. Or take the GPS system on your phone. This is even more incredible. It relies directly on Einstein's theories of special and general relativity. The system has to constantly crunch mathematical adjustments because time actually moves differently for the satellites in orbit than it does for you standing down on the ground. From the MRI machines saving lives in hospitals to the quantum tunneling principles that allow the tiny semiconductors in your laptop to even function, applied physical theories are fundamentally running our modern society.
Finally, let's move to Section 5, the edge of the unknown. We're going to look at some massive unsolved mysteries. Even with all our incredible progress, mapping the human genome, putting rovers on Mars, the universe is still full of massive, glaring mysteries. For instance, those reliable laws of gravity we talked about, they completely break down at the quantum level, which has sparked this frantic search for a theory of quantum gravity. We still have absolutely no idea what dark matter actually is. It's this invisible, undetectable mass that is somehow holding entire galaxies together. Nor do we understand dark energy, the mysterious, pervasive force that is somehow accelerating the expansion of the universe itself. And of course, the ultimate holy grail of physics, a unified theory that connects all four fundamental forces into one elegant master equation, well, that still evades the greatest minds on Earth. The frontier of physics is still wide open.
So where does that leave us? Well, physics ultimately forces us to confront the most profound philosophical questions imaginable. What actually is reality? Is time simply a persistent illusion? If the universe is governed by strict, unbreakable mathematical laws of cause and effect, is everything predetermined from the Big Bang onward, or do we as humans possess actual free will? As we continue to decode the invisible mechanics of the cosmos, we aren't just studying matter and energy. We're trying to figure out exactly what kind of universe we've woken up in. The rules are out there. We just have to find them.